This conference will now be recorded.
Thank you. A big thank you to everyone who attended the first session, and we look forward to seeing you in the subsequent sessions. Just before we start today, I just want to make a few things very clear. This webinar will be conducted in a slightly different manner than the other webinars, in the sense that it's now compulsory for you to attend all 4 webinars to be eligible for a certificate. I'll repeat it in Urdu in case anyone has difficulty understanding. इन वेबिनार्स के लिए हमारे 4 वेबिनार्स होंगे। हर वेबिनार के एंड पे मैं एवैल्यूएशन लिंक चैट बॉक्स के अंदर लिखूंगी आखिरी 10 मिनट में। जो लोग वो लिंक खोल के एवैल्यूएशन को फिल करेंगे अपने ठीक ईमेल एड्रेस के साथ, लास्ट टाइम थोड़े से इश्यूज हो रहे थे जिस आप लोगों के ईमेल एड्रेस ठीक नहीं थे, तो जब मैं क्विज सेंड कर रही थी वो वापस बाउंस बैक हो रहे थे। तो जब आप एवैल्यूएशन को फिल करेंगे अपने ठीक ईमेल एड्रेस के साथ, हम उस ईमेल एड्रेस पे आपको क्विज सेंड करेंगे। जब आपकी एवैल्यूएशन एंड क्विज कंप्लीट होगी, उससे हम आपकी अटेंडेंस मार्क करेंगे। तो आई रिपीट, आखिरी 15 मिनट में चैट बॉक्स के अंदर मैं एवैल्यूएशन लिंक सेंड करूंगी। आप प्लीज उस लिंक पे क्लिक करें, उसको फिल करें। जो आप ईमेल एड्रेस जिस यूज करेंगे उसके अंदर लिखेंगे, उस पे आपको क्विज आएगा। जब आप क्विज कंप्लीट करेंगे, वी विल देन कंसिडर कि आपने ये सेशन अटेंड किया था। तो 3 prerequisites for eligibility for certificates is attending this live session, filling out the evaluation, जिसकी basis पे you will receive the quiz, and then filling out the quiz. Obviously, this does not apply to the first session क्योंकि उस वक्त काफी लोगों को ये रूल का पता नहीं था, लेकिन अब भी क्लियर हो गया। तो इसलिए प्लीज एवैल्यूएशन को आखिरी 10 मिनट में आएगी, उसको क्लिक करके फिल कर देना, उसके ऊपर आपका क्विज आएगा। And then with that, I would like to introduce our speakers today. As usual, we have with us Dr. Philippe Stroot from Xibios Biosafety Consultancy. And today, doing the Urdu translations, we have the Islamabad chapter head for PEPSA, Dr. Shazia Adil. Philippe, would you like to start today's session then? Thank you.
Yes, of course. Thank you very much, Faria. Good evening, everybody. Assalamu alaikum. So today we'll really speak about the new WHO approach. So it's really the core part of this webinar. Perhaps an explanation to the requirement that all of you attend to all the sessions to get the certificate. Actually, the reason for that is that after this, probably at the end of this year, we'll have some in-presence, some real workshops. And for this workshop, we'll jump directly into some exercises and so on. And so it's very important that all the participants to those workshops have a sufficient understanding, at least of the principle of this new approach. So what will we cover today? So first, I will try to show you why we needed a new approach, why WHO decided to propose this new approach. And then we'll really dig into the new approach in presenting the general principles, how does that work, and then underline already some differences with the previous approach, and also the interest for a country like Pakistan. So during the previous session, I presented the classical approach, and that's biological risk assessment. In this case, is done as it's a 2-step methodology. During the first step, we only look at the biological agents, and then we define all their characteristics in line with their pathogenicity, transmissibility, resistance, and so on, and ascribe them a hazard group, which is a kind of summary of the level of hazard they represent. Once we know the biological agent, then we look at what we do with the biological agent. So we look at the activity and we analyze the risk of the activity. At the end of that, we define a risk class for the activity. And the risk class of the activity is what, in the classical approach, defines the biosafety level that we need, and also all the risk control measures. Some risk control measures that could be associated with the biosafety level, and some possible additional risk control measures. Already one reason why there was a reason to change is that this process, 2-step process, is not so well understood by many people. So people tend to define the biosafety level not on the analysis of the risk class of the activity, but on the hazard group of the biological agent. And I showed you during the first session that it should not be like that, and that there could be very different conclusions if you proceed to the risk class of the risk analysis of the activity. So this is still the approach that is used in the Western world, and which is part of our regulations. And it's the case in Canada, in the US, also in Europe. I will mostly base my presentation here on European countries because I know those regulations better. So first, there are some official hazard group classification lists that are published by the authorities. And then the risk assessment is the responsibility of the institution. The institution, they conduct their own risk assessment. And based on that risk assessment, they define the biosafety level that they need and also all the control measures that are needed. So that's also done by the institution. And then they provide all that information, risk assessment and the risk control measures, to the authorities, which review that and finally give their approval or not to the activities. Also, there are a number of technical requirements related to the various biosafety levels, partly in the regulation and partly in some guidelines. However, even if there are technical requirements, there are not really technical specifications. There are mostly general principles. So, for instance, we say, the regulation says that at this biosafety level, you need an inward airflow, so a negative pressure, but there is no document that says how much must be negative, okay? Also, there are no universal technical standards. What is presented as universal is usually some standard that is familiar to a company or so, but it's not really universal. And also, there are a very few of those standards that are based on evidence. Most of the time, there are things that people do, but without being really able to demonstrate why they do it and the efficacy of the measures. A third point about that is that there is more or less flexibility depending on the country. And for instance, some technical requirements could be mandatory for a given biosafety level. But if the institution, in their risk assessment, they show that that specific requirements is not needed and does not make sense in that situation, in some countries it's possible to have a derogation and not to apply something which normally should be mandatory. So you see there is some flexibility which is possible in some cases. Is this approach fully satisfying in developing countries? I would say more or less, and I would say that more is mainly where there is some flexibility. In countries where it's applied in a too strict manner, we end up with situations where the measures in place do not really correspond to the situation, and that makes either useless costs or some frustration because people don't have the best possible protection. There are some significant issues there. First, as I said, many biosafety measures are not really evidence-based. And so people may doubt about their actual efficacy and usefulness. And also because of that, people tend to increase, and when I say people, it could be the authority, it could be institution, it could be individual people, tend to increase the measures without a real rationale behind that. And increasing the measures in general means also increasing costs. Then also in the West, we tend to rely on engineering control, everything which is technical engineering, rather than on people and work practices. There are different reasons for that. The first one is that manpower is very expensive in our countries, but the second reason is that it's a business. And that company, they send engineering controls, and so it makes more profit. They make more profit with engineering controls than with any other types of measures. That trend makes it very expensive, both to invest, to purchase new equipment or facilities, but also to operate because of the energy cost, because of the maintenance cost. And then, despite the fact that in many cases, we have nicely built, well-engineered facility, we still have a number of laboratory-acquired infections. We still have biological incidents. So you see, even with all those means, we still have not a very clear situation where the risk is really controlled. So what would be the situation in low resource countries? And this is not just based on Pakistan, but also on my experience in some other countries, basically mainly in Southeast Asia, but not only. So first, many low resource countries also don't have a complete set of biosafety regulations. So the risk there is that because they are pushed to have regulation, the risk is that they adopt some costly rules from the West, but costly rules which are not even evidence-based. So we are not even sure that they work well, and in some cases they don't work so well. So my personal opinion about that is that currently, now, it's probably better for low resource countries not to have prescriptive regulations. Why? Because of the new biosafety manual, you might end up with a new approach also and have some regulations which will be much more flexible and much more adapted to your own situation. Also, I said that during the first session, most lower resource countries, they don't have adapted hazard group classification of their agents. That means that they use lists from the West, and because of that, they tend not to take into consideration the local epidemiology and also the local availability of medical means. That's not taken into account in lists that have been produced in the West. And so because of that, the hazard group that they ascribe to the biological agent might not be the best for their own local context. And sometimes it could lead to a too high classification of the agent. Why? Because in the West, we will tend to classify an exotic agent like coming from Asia, Pakistan, and so on, and that we don't have in our country at a very high level. But that level is only justified in our countries because we don't have those agents and we are afraid that they reach the population. In your country, it should be a lower level. So also, low resource countries usually don't have a real culture and experience in risk assessment. And because of that, they tend to simplify the approach. And so, for instance, to consider as a group, the other group of the agent is equivalent to the biosafety level, and also to copy-paste some technical solutions from the West without a real rationale behind it. And the last point is that's more, it's not really risk management assessment, but risk management. Since there's less capabilities with respect to technical means, there's also some cost and sustainability issues. If for each time we need to make the maintenance of an equipment, we have to call teams from outside the country, it costs much more money, of course. So the consequences for low resource countries, mainly a lack of diagnostic and research capacity. There might be a few well-designed and well-adapted high containment facilities, but most of the time they have some difficulties. But the main problem is that there is a lack of well-equipped lower level laboratories. Also, it's difficult to have laboratories and equipment that are properly checked and maintained, and that's really a major issue. The other consequence is that there is a kind of feeling that good and safe diagnostic and research are not possible without all those technical means. And this is something that WHO is really against. They consider, and I will show you later, that with some more limited means, but using the right measures, we can reach a very good level of protection and thus do very good and safe diagnostic and research. For instance, the type of questions you might be confronted to is, does it make sense, for instance, to use a biosafety cabinet to check bacterial growth on petri dishes? Does it make sense to have a BSL-3 lab to treat TB smears, from tuberculosis smears? Do you need a BSL-3 facility to grow HIV, knowing that it doesn't spread by air and you don't win a major aerosol will not cause a problem to the outside? Also, does it make sense to require, for instance, a BSL-2 lab for PCR amplification and reading of DNA or RNA extracted from hazardous pathogen? Actually, the answer to all those type of questions is probably no. So if we apply that, and in many labs we apply that, we do it when there is not a good reason to do that. But I say it's probably no, but the only reason to know if we need that or not is to conduct a risk assessment. So risk assessment really aims at providing sound answer to such questions. If you ask yourself some of those questions, then you should conduct a risk assessment, and you should end up with a good, sound answer to those questions. So based on all that, WHO made a number of general observations. The first one, and I already told you about that, it's that there is a misconception, which is quite general, that hazard groups is the same as biosafety level. And this is something which is wrong, and that I used that during the first session. Another observation is that human factors are generally the cause of laboratory-acquired incidents and other accidents, rather than malfunction of engineering controls. And it is the case even in sophisticated, well-engineered facilities. So independent from that, there are still lies and other incidents, and most of the time the reason is about human factors. Third observation is that good microbiological practices and procedures are sufficient to control the risk in most situations commonly encountered in labs. That means that in most situations we may be in when doing some diagnostic, when doing some research and so on, just using good microbiological practices and procedures together with some basic protective equipment will be sufficient to work at a safe level. The last observation is that the best design and the most engineered laboratory is only as good as its least trained worker. So clearly, in saying that, WHO focuses on the work practices and on the need to have workers well trained. So the new idea of WHO regarding biorisk management is that risk should be managed through a practical, risk-based and evidence-based approach, rather than on sort of rules and an application of standards. Then also, they want to put the emphasis on risk assessment and training in good microbiological practices and procedure, rather than engineering control. So clearly, the focus should be risk assessment, and also put measures related to GMPPs in place associated with good training. Also, risk assessment should take all aspects into consideration, not just the biological agent and their characteristics, but also the activities, and then a number of local or institutional aspects, like the local epidemiological situation, the availability, local availability of medical means, the level of training and experience of the staff who will work on that project, the local availability of technical and logistic means, and so on. And then the fourth aspect is the flexibility in the implementation of adapted and sustainable solution. That means that we need to find solutions that we can apply in our institution. And the result of that is that two activities which are more or less similar could be conducted a different way in two institutions. Institution A, for instance, they might have some equipment and decide that they protect the people this way, while in another one they don't have that equipment and they might rely much more on different work practices and personal protective equipment and so on. So flexibility means that not everybody needs to do things the same way, provided the solution is adapted to their own risk, and their own capabilities. So what WHO proposes to move from there? The first thing is that they want really to insist on risk assessment, and also how it should be performed. That means training on risk assessment. And clearly this workshop, this webinar is really in that framework. Then they also want to remove hazard groups and biosafety levels at the global level to allow more appropriate, practical and flexible measures to put in place to mitigate the risk. When they say at the global level, that means at the international level. But of course, if some regulations already are already based on hazard groups and biosafety level, it should not be removed. It can still exist at local level, provided it gives appropriate solutions. But globally, it should not be the case. They really want to focus on good microbiological practices and procedures, and that's this associated with a lot of training and on-the-job training, so really practical training. And they also want to remove the wish for unnecessary, complex, and unsustainable expensive facilities. So it's a trend that authorities, that some institutions, they want to have a BSL-3 that is nice and complex and so on, but most of the time it's not sustainable. And OW wants to remove that desire for such a facility and instead put in place things that are much more operational and much more sustainable. So what is the overall purpose of WHO when doing that? Actually, WHO clearly states that they want to enable all countries to implement economically feasible and sustainable biosafety and biosecurity policies and practices that are relevant to the individual context and priorities. So they want to provide a system that allows all organizations in any country to develop their own way of doing things in a safe way from the biosafety standpoint and biosecurity standpoint. So Shasia, could you please summarize this part in Urdu, and I will see if there are any questions I could answer right now. Thank you very much.
अस्सलामुअलैकुम जी। इस सेशन में आज हम WHO के नए तरीकाकार के बारे में बात करेंगे। WHO का नया तरीकाकार क्या है, ये कैसे काम करता है और पाकिस्तान जैसे मुल्क में इसके लिए इसमें क्या दिलचस्पी हो सकती है। क्लासिकी नुक्ताए नजर में हयातियाती रिस्क की तशखीस खतरा ग्रुप और हयातियाती एजेंटों की खसूसियात और खतरा क्लास की सरगर्मी पे होती थी, जबकि हयातियाती रिस्क मैनेजमेंट के लिए बायोसेफ्टी लेवल और रिस्क कंट्रोल के इकदाम पर गौर किया जाता था। मगरबी दुनिया में रिस्क की तशखीस के लिए ज़ाब्ते की बुनियाद पर होती थी। हुक्काम के जरिए रिस्क ग्रुप की दर्जाबंदी की जाती थी और कंट्रोल के इक़दाम जो रिस्क की तशखीस के लिए होते थे अदारों के जरिए करते थे और हुक्काम उसका मंजूरी देते थे। इस नुक्ता नज़र में कमोबेश हर जगह लचक मौजूद थी और बहुत सारे बायोसेफ्टी के इकदाम सबूत पर मबनी नहीं हैं और इनकी असल अफादियत के बारे में शकूक हैं। मगरब में लोगों और काम के तरीकों के बजाय इंजीनियरिंग कंट्रोल पर ज्यादा इन्हिसार किया जाता है। कम वसाइल वाले मुमालिक में अमूमन बायोसेफ्टी के जवाबत मौजूद नहीं हैं, जिसकी वजह से मगरबी ऐबदार मगर महंगे जवाबत पर अमल किया होता है। मकामी वबाई अमराज और तिब्बी ज़राए पर गौर न होने की वजह से आसान रास्ता अपनाया जाता है, जिसमें BSL को हैजर्ड ग्रुप के मसावी कर देते हैं। इसके नताइज क्या निकलते हैं कि तशखीसी और तकनीकी सलाहियतों का फुकदान होता है। निचली सतह की लेबॉर्ट्री में सहूलियात का फुकदान भी है और लेबॉर्ट्रियों के आलात की जांच पड़ताल और देखभाल में मुश्किलात होती हैं, जिसकी वजह से मायूसी का अंतर गालिब रहता है। कुछ सवाल जिनका हमें सामना करना पड़ता है कि टीबी के स्मीयर्स की ट्रीटमेंट के लिए BSL-3 की लैब होनी चाहिए, डेंगू की अफजाइश के लिए BSL-3 की लैब होनी चाहिए, PCR की एम्प्लीफिकेशन के लिए BSL-2 या BSL-3 लैब होनी चाहिए। इन तमाम सवालात का जवाब नहीं में है, क्योंकि खतरात की तशखीस का मकसद इस तरह के सवालात के जवाबात फराहम करता है। WHO के जरिए कुछ अमूमी मुशाहिदात WHO ने किए। सबसे बड़ी गलतफहमी खतरा ग्रुप बायोसेफ्टी लेवल के बराबर है। दूसरी, इंजीनियरिंग कंट्रोल में खराबी के बजाय इंसानी अवामिल आमतौर पर लैब में हादसात का सबब बनते हैं और अमूमन अच्छी माइक्रोबायोलॉजिकल तराकीब पर काम करके खतरों से बचा जा सकता है। नया नमूना क्या कहता है कि सबूत पर मबनी नुक्ता नज़र के तहत खतरात को कम करें, खतरात की तशखीस और के लिए और बेहतरीन GMPP की तरबियत पर जोर दें और खतरे की तशखीस के लिए तमाम पहलुओं को मद्देनजर रखें, जिसमें अमला की तरबियत और मकामी दस्तयाब तकनीकी सहूलियात वगैरह शामिल हैं। इसके अलावा WHO कहता है कि खतरात को कम करने के लिए आलमी सतह पर हैजर्ड ग्रुप्स और बायोसेफ्टी लेवल हटा दें, हकीकी और अमली इकदाम पर अमल करें, इस बात को उजागर करें कि खतरे की तशखीस क्या है और उसको कैसे अंजाम दिया जाना चाहिए, और GMPP और मुलाजमीन की अहलियत और तरबियत पर जोर दें। नई WHO का और लेबॉर्ट्री बायोसेफ्टी मैनुअल का मजमूई मकसद ये है कि तमाम ममालिक को मुआशी तौर पर मुमकिना और पायदार बायोसेफ्टी और सिक्योरिटी पॉलिसियों और तरीकों को नाफिज करने के काबिल बनाएं जो इनफरादी सियाको सबाक और तरजीहात से मुताबिकत रखते हैं। Over to you, Philippe.
Thank you, Shazia. So clearly, WHO they developed this new laboratory biosafety manual on the basis of observation that have been made during years, and really with the idea to change the way we approach biosafety in the future. So it's not based on a current situation in like COVID crisis or anything like that. It's something that has matured for many years before coming out. It was actually published at the end of last year. So now I will present you the new biological risk assessment approach. So first, it's again a stepwise process, and during that process we evaluate the risk arising from working with some hazardous biological agents or materials. And we use that information from the risk assessment to define whether risk control measures can be applied or not, and what type of risk control measures should be put in place. Also, I want to insist on the fact that risk assessment is a systematic process. It must always be done in the same way, in a standardized way, to ensure that the results are repeatable, comparable, and so on. Meaning that if we do risk assessment of an activity, then we have another activity, we do it the same way on the same basis. So in this case, the risk assessment is done in 5 steps. The first step is to gather the information, and you will see that it's not just the information on the biological agent and on the activities, but also on a number of other aspects, mainly related to the local situation. Then, on the basis of that information, as step 2, we evaluate the risk. After the risk evaluation, and those are more or less the first steps of the classical way, we develop a risk control strategy. And from that risk control strategy, we select and implement a number of specific risk control measures. Why to do it in 2 parts? Because first we need to have a global evaluation of the situation, and also look globally at what approach is possible before starting to define specific measures. And so this is why WHO made that in 2 steps. And then the last part is reviewing the risk and the risk control measures on regular interval afterward. Why? Because things might have changed, for instance. So I will cover the different steps now. First step is gathering the information, and for instance, what type of biological agents will be used, what are their characteristics relevant to transmission, pathogenicity, and so on, and what laboratory work and procedures will be conducted. That's what we do also in the classical approach. But in addition to that, we also look and we also gather information about the type of laboratory facility that is available. How does it work? Do we have a ventilation system? How does it work? Do we have filters and so on? Also, what are the equipment and logistic means that we have in this laboratory or in this institution? Then we also look at and gather information on human factors. What is the training of the people? What is the experience in that type of work? What is their medical status? Are they vaccinated? And so on and so on. And we also look at some possible other factors, like some local conditions, some possible legal aspects, some cultural issues, also possibly the socio-economic situation, and so on. So we really gather a maximum information about all those aspects. Using that, then we evaluate the risk, and that's really the core part of risk assessment, of course. So the first question is the same as in the classical approach: how could an exposure or release occur during the activity? And so we define those, the way they could occur, in which situation, how this would happen, and so on. That's the same as in the classical approach. Then we look at the likelihood of an exposure or release. That's also almost the same as in the classical approach. We identify the factors that are likely to influence the likelihood of an incident. I took a number of examples there. I will not go through that, but just the first bullet, for instance. If you use sharps, in that case, you have a higher likelihood of percutaneous exposure. I mean, to accidental injection or cutting yourself with those sharps and provoking an infection by exposing your blood, for instance. So there are a number of things like that that really increase the likelihood of exposure when compared to the situation where you would not do that. Another example, if you work on highly resistant biological agents, in that case, if there is even a minor spill or aerosol, they will be more resistant on surfaces and also on your hands, on clothes, and so on, but also in waste. Because of that, there is a higher likelihood of exposure by some different means, because people could get into contact with those resistant organisms, but also there is a higher likelihood of release and survival in the environment to contaminated waste, to contaminated items, and because of that, the population could also be exposed. So when we have evaluated the likelihood, we also evaluate the consequence of an exposure and a release. So identify again the factors that are likely to influence the consequence of an incident. I also take some examples here. I will also, just the first bullet point, if the agent is highly transmissible, in that case, that means a single exposure of one individual may result in infecting more people and spread to the community, because once that person is infected, if there is the infection developed, that people will infect other people. So there, the consequence will be more severe than just on one individual, but there will be more people involved. Some factors might also affect both likelihood and consequence. If, for instance, you work with an agent that has a low infectious dose, meaning that only a very few viral or bacterial particles are enough to infect someone, that means that the probability of an exposure and infection is higher, because even a small quantity will be sufficient, but also you could be exposed to more severe consequences, because if you are exposed to larger quantities, in that case, you might have more severe presentations of the disease. So you see, these are a number of factors. I did not go through all of them, but that are likely to, in some way, increase likelihood or consequence and thus increase the risk. Based on that, we define what is the initial risk of the activities that we plan. Initial risk means without any measures in place or without any specific measures. That means the laboratory working as normal. And for that, we use the risk assessment matrix. And this is, in one direction, you have likelihood, and in the other, you have consequences. And so for instance, an exposure that would have a very high likelihood would be in this area, in this last column. If the consequence is also very high, the consequences are severe, you would in the red area. And so you can, for all the activities or part of the activities, you can build such a risk assessment matrix. And this will be helpful to prioritize risk control measure. It's clear that when you see that, you should first act on the part which is in red and orange, and then move to yellow. And if you consider it still not acceptable to be in light green, you could still work on that. And that's the next step. We need to, in the process itself, we need to define of those risks, which ones could be considered acceptable and which ones would not be acceptable. When we do that, actually, what we draw a kind of line between what we consider as acceptable and what is not acceptable. And also, we define a benchmark below which we absolutely need to reduce the level of risk. In doing that, we need to keep a number of things in mind. First one is that there is nothing like zero risk. That does not exist. So the risk cannot never be completely eliminated, at least if you do the activity. Of course, you could decide not to do the activity if you don't have the means. Also, if defining acceptability or not is a little bit subjective, it's very important to do it, because the risk assessment process is based on that. That means that you need to, in some way, to have several people deciding, okay, this is something we don't want to see in our facilities. This is something that we consider as not acceptable. Why this risk, which is very low, in that case, we can live with it. Also, it's not just to look at acceptable risk or not acceptable risk just on facts and data. As scientists, we are used to mainly treat facts and data, but we should also think about the way the risks are perceived by the personnel. Why? Because if you consider on the basis of facts and data that the level of risk is low and acceptable, but that the personnel has the feeling that it is a very high risk and that they don't want to accept it, they will not really be confident with the measures you will propose, and you will have a problem of compliance with those measures. And so that means that in that case, if the personnel perceives the risk as higher as it is, either you need to still put more measures in place, or to communicate about this, to explain why it is not the case. But that means that you also need to take that into consideration. So the next step, once we have evaluated the risk, is to define what is not acceptable, is to see how what is not acceptable can be controlled. And that's where we start developing the risk control strategy. We need to look at the needs, what risk needs to be reduced, and then what resources we have. What are our human resources? The staff working in the lab, but also the logistic. What kind of equipment do we have? Are those pieces of equipment in a good state or not, and so on. Also, what risk control measures are applicable with the available resource, with the resource we have in this institution. And also, are those resources sufficient to maintain those risk control strategy in the future? If not, we'll need to find a solution for that. And you should also ask questions like if external factors may influence the risk control strategy. It may be that some protective equipment might not be available all the time because it's imported and you cannot have large stocks of it. For instance, if you plan to treat waste with the incinerator that is on site but in the middle of the city, you might have some opposition from the neighbors to incineration. And so all that also needs to be taken into consideration, at least when establishing the strategy. And then when you do that, you define and you decide for one of these, the possible control strategy, the one which is the most effective and that also that remains sustainable and achievable in the future. So the main types of risk control strategies, first, elimination. That means that we suppress, we eliminate the hazard. For instance, we inactivate the biological agent, or we use something which is not infectious. We use another strain which has some of the same characteristics, but which is not hazardous. We could also reduce or substitute the hazard of the risk. It's, for instance, to use an attenuate viral strain instead of a virulent strain. You could also use smaller volume or smaller concentration. You could also change a procedure. For instance, work on a solid culture instead of a liquid culture. You reduce the risk of aerosols. Or use PCR instead of some identification process that requires some culture of the agent. You could also do isolation, which means isolate the hazard. If in your process you just have one activity which is at high risk, in that case you could conduct that activity in a very small equipment or a room that is highly protected. And so that means that you use primary or secondary containment in this case. Then all the rest is protection and mitigation. That's the application of work practice, wearing PPE and so on, use engineering control. Vaccination is also part of that. And then in addition to that, you have administrative control, which are all the controls that are provided by the management of the situation, about communication, standard operating procedures, training, promoting a safety culture, also all the checking process like inspection and audits, for instance. Once the strategy is defined, then you need to select and implement risk control measures. And that's much more pragmatic work. It's really people who know the work on the field that need to work on this. And so you should look at what is locally available and sustainable as protection means, for instance. Also, are all those techniques or equipment equally sufficient, or do you need to combine them? And then when you decide about that, you can also define, okay, after putting those measures in place, that will be the level of risk, what we call the residual risk. So with the risk control measures in place. Question we might also ask ourselves is that complying with existing regulations, either local regulation or international. And then practical things about implementation. How can we communicate that to the staff? How will we train the people be working on this? Do we have the budget to include the protective equipment or maintenance of validation of biosafety cabinets? Do we have the money for that? And when everything is in place with the procedures and so on, then you can really implement the risk control measures. And then the last step, step number 5, that's the risk, the review of the risk and the risk control measures. And that should normally be done on a regular basis. Why? Because things move over time. There might be some new knowledge available on the biological agents or on the process that are being used. But you could also have changes in the biological agents that you use, in the activities, in the personnel, the technology that's used, possibly also in the equipment and facilities. Also, if there is an accident, then in that case, there might be some good lessons to learn from those incidents. So that's why it's important to do that on a regular basis, or in any case, if there is a major change in all those processes. And the question then, we should check that the risk control measures that are in place are still sufficient to really control the risk, or if we need to adapt them and in order to keep it efficient. Also, there is always the question, can we improve things? And that should also be considered during that review. So in this graph, I kind of summarize the whole process of risk assessment and with the questions that we have to ask. So the 2 first steps, gather information and evaluate the risk. At the end of that process, we have to ask ourselves the question, is that risk, or are those risks acceptable? If yes, then you can proceed with work. You can work as usual, I would say. If no, in that case, we need to establish a risk control strategy to work on the risks that are not acceptable. Risk control strategy, and also select and implement the risk control measures. Okay. Once we have that in mind, when it's ready, we should again ask ourselves the questions, are these risks acceptable with these measures in place? If yes, we can proceed with the work in using those measures. If no, then we should ask ourselves, are additional measures feasible? Because perhaps if we didn't think of those measures when selecting control measures, it's perhaps because they are not available locally. Anyways, if additional measures are feasible, in that case, we should select those measures and then again ask ourselves. If not, we should revise or close the project. So that's a possible outcome of risk assessment. We might at the end decide that with our facilities, with our people, with all the means we have, it's not possible to conduct the project. That would be the case if you have some basic facilities, for instance, and some institution propose you to work on Ebola with some culture of Ebola. It's obvious that in that case, if you do this, you will end up with a situation where you cannot control those risks. And in that case, the issue would be not to proceed with work, but to revise or close the project. Okay. So now, again, it's time for the summary in Urdu. Shazia?
حیاتیاتی رسک کی تشخیص ایک مرحلہ وار عمل ہے۔ رسک مضر صحت حیاتیاتی مادوں کے ساتھ کام کرنے کے لیے پیدا ہونے والے خطرات کا اندازہ کیا جاتا ہے اور خطرے کو قابل قبول سطح پر لانے کے لیے رسک کنٹرول کے اقدامات لاگو کیے جاتے ہیں۔ رسک کا تخمینہ ایک منظم عمل ہے، اس کو یقینی بنانے کے لیے ہمیشہ معیاری انداز میں انجام دیا جاتا ہے۔ نیا طریقہ کار 5 مرحلوں میں رسک کی تشخیص کرتا ہے: معلومات جمع کرنا، خطرات کا اندازہ کرنا، رسک کنٹرول پر حکمت عملی تیار کرنا، رسک کنٹرول کے اقدامات کا منتخب کرنا اور ان پر عمل کرنا، اور 5واں رسک اور رسک کنٹرول کے اقدامات کا جائزہ لینا۔ مرحلہ نمبر 1: معلومات جمع کرنا۔ کون سے حیاتیاتی ایجنٹوں پر کون سا کام ہو رہا ہے، ان کی پیتھوجینسٹی کے متعلق کیا خصوصیات ہیں، سامان اور رسد کے ذرائع اور انسانی عوامل کون سے موجود ہیں۔ دوسرا مرحلہ: خطرات کا اندازہ کرنا۔ حیاتیاتی ایجنٹوں کی ریلیز کیسے ہو سکتی ہے، طریقے کیا ہیں، ان کا امکان کتنا فیصد ہے اور متاثر کرنے والے کون کون سے عوامل شامل ہیں۔ اس کی کچھ مثالیں ہیں کہ امکانات پر اثر انداز کرنے والے کون سے عوامل ہو سکتے ہیں، جیسا کہ شارپس کا استعمال، کم تربیت یافتہ افرادی قوت اور ایروسول پیدا کرنے والی سرگرمیاں۔ اس کے علاوہ دوسری جو مثال ہو سکتی ہے کہ انتہائی مزاحمتی حیاتیاتی ایجنٹوں پر جب کام کریں گے تو رسک کے امکانات زیادہ ہو جاتے ہیں۔ تو تب ہم رسک خطرات کا اندازہ کرنے کے لیے نمائش سے ریلیز کے نتائج کیسے ہو سکتے ہیں، اس واقعے کے نتائج کو متاثر کرنے والے عوامل کی نشاندہی کریں گے۔ کسی واقعے کے نتائج کو متاثر کرنے والے عوامل میں اگر ایجنٹ کی ٹرانسمیبلٹی زیادہ ہے تو اکیلی نمائش کے نتیجے میں زیادہ سے زیادہ افراد کو متاثر کر سکتا ہے اور معاشرے میں بھی پھیل سکتا ہے۔ کم متعدی خوراک والا ایجنٹ بھی تھوڑی سی مقدار میں نمائش سے انفیکشن اور بیماری پیدا کر سکتا ہے، اور اگر زیادہ مقدار میں جائے گا تو زیادہ انفیکشن اور زیادہ بیماری پیدا کر سکتا ہے۔ ان سب چیزوں کے لیے ہم کریں گے سرگرمیوں کا مجموعی ابتدائی خطرہ دیکھیں گے۔ مجموعی ابتدائی خطرہ کے تعین کے لیے ہم رسک اسیسمنٹ میٹرکس کا استعمال کرتے ہیں، جس میں ہم رسک کنٹرول کے حکمت عملی کے اقدامات کی ترجیح کو تفویض کیا جاتا ہے، جو کہ نمائش یا رہائی کے نتائج اور ایک دوسری طرف نمائش یا رہائی کے امکانات کو ظاہر کرتا ہے۔ خطرے کا اندازہ کرنے کے لیے ابتدائی خطرے کی تشخیص کے بعد لیب یہ دیکھے گی کہ ان سرگرمیوں کے لیے قابل قبول خطرہ کیا ہے اور کون سے خطرات ناقابل قبول ہیں۔ لیب میں کون سا خطرہ قابل قبول ہے اور کون سا خطرہ ناقابل قبول، اس بات کا تعین کرنے کے لیے ایک بینچ مارک کا بنانا بہت ضروری ہے، کیونکہ خطرے کو کبھی بھی مکمل طور پر ختم نہیں کیا جاتا، اسے صرف کم کیا جا سکتا ہے۔ کیا ناقابل قبول خطرات پر قابو پایا جا سکتا ہے اور کیسے پائیں گے، اس کو ہم اگلے دیکھتے ہیں۔ تیسرا مرحلہ رسک کنٹرول پر حکمت عملی کی تیاری ہے۔ یہ دیکھنا ہے کہ کون سے وسائل خطرات پر قابو پانے کے لیے دستیاب ہیں اور کنٹرول کی کون سی حکمت عملی مقامی تناظر میں سب سے زیادہ مؤثر، پائیدار اور قابل حصول ہے۔ رسک کنٹرول حکمت عملی کی کچھ اہم طریقے ہیں، جیسے کہ خطرہ کا خاتمہ، خطرے میں کمی یا متبادل، اور انتظامی امور میں کنٹرول پر اتنی بہتری لے کے آنا کہ عملے، برادری اور ماحول کے اس کی زیادہ اچھے طریقے سے حفاظت ہو سکے۔ ایک اچھی رسک کنٹرول کی حکمت عملی کی خصوصیت یہ ہے کہ وہ ایک مجموعی سمت دے، قابل حصول ہو اور ادارے کے مجموعی اہداف کے ساتھ اس کی صف بندی ہو۔ رسک کنٹرول کے اقدامات کو منتخب کرنے اور ان پر عمل کرنا ہمارا 5واں مرحلہ۔ اسکپ کر گئی ہوں۔ سلائیڈ 5 جو ہے رسک اور رسک کنٹرول کے اقدامات کا جائزہ لینے کے لیے دیکھیں گے کہ ایجنٹ، سرگرمیوں، اہلکاروں اور دستیاب ساز و سامان کی کوئی تبدیلی آئی ہے۔ رسک کنٹرول کے اقدامات اس طرح ڈھالیں کہ وہ مستقل، زیادہ مؤثر طریقے سے رسک کو ختم کر سکیں۔ اس سلائیڈ میں ہمیں رسک کنٹرول کی تشخیص کے عمل اور ممکنہ نتائج کا ایک خلاصہ دیں گے کہ پہلا مرحلہ معلومات کو جمع کرنا ہے، دوسرا مرحلے میں خطرات کا اندازہ کرنا ہے۔ جب ہم خطرات کا اندازہ کر لیں گے تو ہم ابتدائی خطرہ ہمارے لیے اگر قابل قبول ہے تو ہم اپنے کام کو کریں گے، اگر ابتدائی خطرہ ہمارے لیے قابل قبول نہیں ہے تو ہم رسک کنٹرول پر حکمت عملی کو تیار کریں گے، رسک کنٹرول کے اقدامات منتخب کریں گے اور اپنے کام کو ریویو کریں گے۔ जब उन पर अमल कर लेंगे तो हम देखेंगे कि बकाया खतरा हमारे लिए काबिल कबूल है। अगर बकाया खतरा हमारे लिए काबिल कबूल है तो हम अपने रिस्क और रिस्क कंट्रोल के इकदामात का जायजा लेंगे। अगर वो हमारे लिए काबिल कबूल नहीं है तो मुमकिना इजाफी इकदामात की जरूरत को देखेंगे कि उनको हमें उनकी जरूरत है या नहीं, और उसके इन बेसिस के ऊपर प्रोजेक्ट पर नजरसानी करेंगे और अपना प्रोजेक्ट हम आगे बढ़ा सकते हैं या बंद कर सकते हैं। ओवर टू यू फिलिप।
Thank you, Shadia. Yeah, there are very few questions, and I will not answer them now. I think we will have some answer to those questions during the next session. And anyways, the fourth session will be devoted to questions. In this last part, which is very short, I will make the link between the risk assessment and the risk control measures according to that new WHO approach. So this is this is the risk assessment matrix, and you see in green the risks that are more or less acceptable. Then in yellow the risk that comes from situations that are highly likely to occur or that that have moderate to severe consequences. And then in red you have the risk of exposure or release with a high likelihood and severe consequences. And according to WHO, most of this part, the green part, that means that covers most laboratory activities, the risk can be mitigated, the risk can be controlled with core requirements. So that's really what WHO says. While the area which is in yellow, in that case, the risk can be controlled with some selected high-level control measures. And they insist on selected. It's not just put a number of high-level control measures in place. It's really to select the one which help to cope, to control the risk that we have identified the risk during the risk assessment. And then this area in red, that's high likelihood, high consequence. In that case, those are the few laboratory activities that require maximum containment measures. But again, there it's a selection of the maximum containment measures. It might not be all the containment measures. So for the green part, in that case, that's a part where most activities can be used, can be executed safely using core requirements. What are those core requirements? Actually, it's the good microbiological practices and procedures. It's some basic protective measure, including some basic personal protective equipment, like a lab coat, like gloves. It's basic laboratory facilities. You don't need fancy ventilation system, fancy equipment or anything like that. Basic decontamination practices, meaning using some usual disinfectant, and it's also based on training. Okay. Then the part in yellow, so that have a higher likelihood or a more severe outcome. In that case, you might need some selected high-level control measures. An example of those high-level control measures is, for instance, higher level work practice. So, for instance, we'll work for some activities using 2 pairs of gloves. We could also use more PPE, specialized personal protective equipment, like a respiratory mask, for instance. Also, the facility, we could have an anteroom to enter the lab so that we can better segregate the activities within the lab. We could have some engineering controls, like a negative pressure, or possibly HEPA filters and so on. We could use biosafety cabinets. You see that biosafety cabinets, according to WHO, that's not part of the core requirements. Biosafety cabinets should only be there and be used when there is a reason to use it. That means that where there is a high likelihood, a high severe outcome, when there is a high risk that can be prevented by the use of a biosafety cabinet. So that's quite different from the logics we generally have in mind. We could also need to use dedicated equipment. We could have on-site decontamination facilities like large autoclaves or incineration. And since all those practices require some more know-how and so on, additional training. And then for the few laboratories with a very high risk, in that case, they might require some maximum containment measures. Examples of that are very efficient primary and secondary containment systems. So like, for instance, facilities that are airtight with a strong negative pressure, pressure differential, full PPE, like a full positive suit, like a class 3 biosafety cabinet, for instance. Decontamination, total decontamination of all existing material, high-level training or associated to all that. So those are examples of maximum containment measures. Again, you don't necessarily have all of them in place, like in BSL-3 plus or BSL-4 laboratories. If the risk of your activity is to have a release via the air, through the air, in that case, and no through the effluents, the liquid effluents, in that case, you should not have a effluent decontamination system, but you should have a very good ventilation system with HEPA filters, you see? So even for maximum containment measures, for those few labs that require such containment measures, in that case, you can still select what really helps you to control the risk you have in your activities. So again, Shazia, if you could also summarize this last part.
रिस्क असेसमेंट मैट्रिक्स और इसके इकदामात को चौथे बायोसेफ्टी रिस्क असेसमेंट के मैनुअल में WHO ने 3 दर्जों में किया है। पहला दर्जा बुनियादी ज़रूरियात का है, दूसरे में कंट्रोल के सख्त इकदामात के ऊपर बात की गई है और तीसरा काबू पाने के ज़्यादा से ज़्यादा इकदामात जहां पर हमें ज़रूरत हो। बुनियादी ज़रूरियात का इस्तेमाल करते हुए बेशतर लेबॉर्ट्री की सरगर्मियां महफूज तरीके से अंजाम दी जा सकती हैं और इनको कोर रिक्वायरमेंट या बुनियादी ज़रूरियात कहा गया है। इसकी मिसाल के तौर पर अच्छी माइक्रोबायोलॉजिकल तरीकों को इस्तेमाल करते हुए इसकी मिसाल है। लेबॉर्ट्री की कुछ सरगर्मियों के लिए मुंतखब करदा ऊंचे कंट्रोल के इकदामात की ज़रूरत होती है, जैसा कि बायोसेफ्टी कैबिनेट्स का इस्तेमाल। लेबॉर्ट्रीज के अंदर बहुत कम ऐसे सरगर्मियां होती हैं जिनमें ज़्यादा से ज़्यादा काबू पाने के लिए इक़दामात की ज़रूरत होती है, जैसा कि कुछ ऐसी जगह हैं जहां पर मुकम्मल खुसूसी लैब सूट का पहनना ज़रूरी है। बहुत शुक्रिया।
Thank you, Shazia. Thank you for your attention, I hope. Yes, I hope that with this last part, you see the link between the risk assessment and also the measures that should be much more specific and adapted to the risk and adapted to the situation that you are confronted to locally. And I think that that's really the most important. At this stage, I know that it's still principle, it's still quite theoretical. So, but next time I will use a case study to really develop that risk assessment methodology, so that you already see much more how to apply it. So I hope to see you next time then for that more practical session, even if the real practical session will be working together on some specific situation that you know. Thank you very much, and see you next time. Bye-bye.